So wishing you all a very good morning. Hope all of you are fresh and rejuvenated after coming from the week free. So once again, a quick reminder. What are we doing here? We are doing CCNA-1, Introduction to Networks. Okay. And we have covered the 10 basic chapters, and now we are moving to topic 11, IPv4 addressing. So I just wanted to tell you, if there is anything in this unit that is worth paying much attention to, I mean, all of them are worth, I'm sorry, didn't come out right. What is the most important topic in this unit, perhaps I would say, is this. Topic number 11, IPv4 addressing, because you're going to use this concept in all the CCNAs and also in subsequent, alphabetical Cisco enterprises like CCNP and so on. IPv4 addressing is perhaps one of the most important concepts that you have to learn. Okay, so I would say that in CCNA1, the most important topic is number 11. Okay, as per my experience, because giving an IP address, especially IPv4 address, okay, to your devices and planning it, constitutes the major part of a network engineer's job. So you have to understand this concept very clearly. And so much so, it becomes important because of your skill-based exam. Okay, your skill-based exam is going to incorporate your skills as a network engineer. Okay, and you have got 3 hours, and you have to, the first thing you have to do is give a network address, IPv4 address. Okay, IPv6 is very straightforward. It has been created to be very straightforward. But IPv4, there are certain concepts that you have to understand, especially with regards to subnetting. Okay, so I'll be teaching you this topic, and I hope you are attentive and you can pay attention. In fact, this is one of the favorite topic of mine to teach because it's important, and of course it has got its own challenges. So let's start. Learning about IPv4 addressing. Okay, again, IPv4 is used very much in private enterprises. In public addresses, when it comes to IPv4, we are running out of IPv4 addresses because maximum 4 billion devices, and we have got so many devices, much more than 4 billion in this world. With the advent of IoT technology, there's so many devices that have got network interface card, and they need logical addresses. That's why we have come with a new solution, which is IPv6. Okay, so IPv6 is very straightforward, but I'll be covering IPv6 at 1 p.m. today. If you guys are free, you can come and attend that session as well. Otherwise, you can just watch the recording. Now, let's go to IPv4 and try and understand this concept of IPv4 IP addresses. So the objective today is find out IPv4 addresses and how to do segmentation. In other words, how to do IPv4 segmentation, also known as subnetting. So we are going to look at the structure of an IPv4 address. Okay, So an IP version 4 address has got two portions. It has got a network portion and a host portion. And we are going to find out which is the network portion, which is the host portion. Remember, the host portion is the one that changes. Okay, it tells you how many devices you have. The network portion is always constant. Okay, and how do you know how to divide the network portion and the host portion? You need something which is called subnet mask. Once the subnet mask is given to you, then you can divide which is the network portion, which is the host portion. We will look at IP version 4 unicast, broadcast, and multicast. We will look at the different kinds of IP version 4 addresses. What are public addresses? What are private addresses? What are the reserved IP version 4 addresses? Then we will go to network segmentation. Okay, we will learn how to perhaps do subnetting. Okay, how do we do subnetting? How can we take one network and subdivide it into smaller networks? Okay, why do we do segmentation in the first place? Why do we make our life miserable and make things more complicated? There's a reason. We'll be studying that as well. Okay, and finally, yeah, we will subnet an IP version 4 network. So I hope you have brought your attention span to this session. It's going to be a little bit intense, but at the same time, interesting, very interesting. I love teaching, as I told you, this topic. Okay. I remember the first time, it was more than 10 years, or actually more than that, I think 10, 15 years ago, the first time I came across this topic, and my instructor, my lecturer teaching me this, I seriously couldn't understand what they were talking about. I remember, but then I explored and explored and explored, and then I understood. And I hope in today's lecture, you don't have the same experience. You understand what I'm talking about, okay? I'm recording the session, and you can obviously go through it at a later time. But anyway, I've tried to make the session interesting at the same time, try to show you actually how an IP version 4 address is given and calculated, how the subnets are calculated. So let's start. First of all, IP version 4 address structure. Now, I've told you since the beginning, I've prepared the foundation for all of you. I have told you that an IP version 4 address consists of two portions, okay? Consists of two portions. Now, we have studied that we have got the network portion, yes, and we have got the host portion. Network portion is always constant. It doesn't changes. It doesn't change. The host portion changes. Now, how do you know which is the network portion, which is the host portion? Very simple. You need something called a subnet mask. You should ask, what is the subnet mask? Okay. This is one of the part of your exams, you're going to do calculation based on this. So you have to ask, what is your subnet mask? Once you have your subnet mask, then you know which is the host portion and which is the network portion. For example, here we can say the subnet mask is 255.255.255.255.0. So the subnet mask means over here, when you convert 255 into binary, it means 1111111. Again, 255 converted into ones. Again, 255 converted into ones. Okay. So the ones is always, all the ones that you have over here is your network. Whenever you see a ones in your subnet mask, that means It is the network portion. So in this IP address consisting of 4 octets, the network portion is 192.168.10. It will never change. It will always be the same. The zeros are the host portion. So this is the part that keeps changing. Okay? So remember, we did the calculation multiple times. How many devices I can connect? How many hosts I can connect? Just count the zeros. 1, 2, 3, 4, 5, 6, 7, 8. 8. So that means 2 to the power of 8 minus 2. Okay, that would be 256 minus 2. That would be 254 hosts, starting from 1 all the way to 254. Okay. So what does that mean? The first IP address for this network will be, what? 192.168.10.1. The last IP address will be 192.168.10.1.254. Okay, so this is very straightforward. Now, there's a special way we can calculate what is the first IP address, what is the last IP address. We'll come to that. Okay, but for now, remember, your IP version 4 is a 32-bit address. Why 32-bit? Because it consists of 32 bits. You see, 8 plus 8 plus 8 plus 8. 8 times 4, 32 bits. 4 octets. Okay. So you should always remember that your IP address has got a network portion and a host portion. Okay. And you can determine what is your network portion and your host portion by something known as a subnet mask. Now, usually it's very cumbersome to give you something like this, 255.255.255.0, this kind of subnet mask. So what people do, okay, when they give you an IP address, instead of giving a subnet mask like that, they just mention the network portion. So in this case, the network portion is 8 plus 8 plus 8. So we can say it's a slash. Let me use a pen. Using a pen also has got its own challenges, my dear students. It is slash 24. Okay. Slash 24 means network portion. That means all the ones is 24 bits. So subnet mask can be represented in this shorthand form or in this form. Okay. Both are acceptable. So this is an introduction to IP version 4 address. Okay. Again, I'll be repeating a lot of things over and over again so that, you know, the concepts is driven home. So over here, the subnet mask given to us is 255.255.255.0. That means 255, that means converted into your binary is all ones. Okay. And all ones is always your network portion. So over here, the network portion, if you count 8 plus 8 plus 8 is 24 bits. What is host portion? 32 minus 24, which is your 8 bits. Okay. So 8 bits is our host portion. And based on the calculation, 2 to the power of 8 minus 2, that means we can have 254 devices in this network. Okay. So remember, count the binary ones to get the network portion, and count the binary zeros to get the host portion. So in the subnet mask, all the ones will be the network portion, or the zeros will be the host portion, always. Okay, very straightforward. There we go. 255.255.255.0. You can represent it in this way, or there's a shorter way to represent it, as I told you. Count the network bits, which is 8 plus 8 plus 8. So you can also represent it like this, /24. This is a shorthand form. So in exam, if I tell you /24, you immediately should know that the subnet mask is 255.255.255.0. In other words, you should immediately know that in this IP address, the network address is this portion. The host is this portion. Okay? So when I give you /24, you know that I'm talking about this subnet mask. Immediately you should know that. Okay? And this is the standard actually. This is how people give the notation. /24 means 255.255.255.0. So look at the prefix length that we have. Okay? So we can mention it like this. You see? We can mention it like this. Okay, 255.0.0.0, or we can mention /8. /8 means 8 bits are for network and host bits are 8 plus 8 plus 8, 24 host bits. 24 host bits, my dear students. Just imagine how many devices you can connect to this network. 20, just imagine, look at the subnet mask, 24 host bits. Okay, just take your calculator. Hold on. Okay, there. Let's go to scientific. Okay, so how many host bits I have? 8 plus 8 plus 8. So that would be 2 to the power of 24 host bits minus 2. That means I can connect 16 million over devices in this network. Okay. So in this /16, how many devices I can connect? You see, look at the host bits, 16. Okay, so that would be, again, 2 to the power of 16 minus 2. 65,534 devices can be connected in this /16 network. /24 is very straightforward. We know /24, that means we can do a straightaway calculation. 2 to the power of how many bits? 1, 2, 3, 4, 5, 6, 7, 8. 2 to the power of 8 minus 2. 254 devices. Okay. Now, it gets a bit trickier. Look over here. /25, /26, /27, /28, /29, and so on. Okay. For example, /27. Why do we say /27? Because you see, we have taken 3 bits from the host portion. You see, normally /24 is straight away divide. Okay, very easy. But when you say /27, that means you have taken 3 more bits from the host portion. So this will translate into 255.255.255. Now 111.0.0.0.0 is 224. So the subnet mask is 255.255.255.224. Yes, you can do this as well. You can convert your /24 into /27. This is called subnetting, making it from 24 to 27. But instead of having 8 host bits, you have now only 1, 2, 3, 4, 5. 5 host bits. Okay? So 5 host bits means, again, go back to your calculator. 2 to the power of 5 equals 32 minus 2. So in /27, you can have only 30 devices. Okay? So /27, you can have only how many? 30 hosts. Okay? So this is how you can represent your subnet masks. Okay? All the way until, I think I have got an example here. Yeah. Okay. All the way until /30. Okay. Now, remember one thing, the last two host portion, the last 2 zeros cannot be subdivided. Okay. This is the most you can go, not more than this. You have to leave at least 2 zeros for the host. Now, when you say over here /30, that means 8 plus 8 plus 8, 24, 25, 26, 27, 28, 29, 30. So here I have got 30 host bits. Sorry, 30 network bits. That means 32 minus 30, only 2 host bits is remaining. Okay? So 2 host bits, again, 2 host bits. How many devices you can have? 2 to the power of 2 equals 4 minus 2 using the formula. That means in a /30 network, okay, in other words, in a subnet mask of 255.255.255.252, you can have only 2 devices. Okay? Only 2 devices. Only 2 devices or 2 hosts. Now you might be thinking, who in their right mind creates this? There is a use for it. You will see very soon that there is a very good use even for this. Okay? We'll come to that very soon. Now, let's move on. Remember, how do you calculate how many hosts? Okay? You calculate by seeing by using the formula 2 to the power of the host portion, the zeros, okay, minus 2. Okay. So how do you find the host portion? That is 32 minus the prefix length. So here the prefix length is, let's say, 28. So 32 minus 28 means the host portion is 4. Just count the zeros. 1, 2, 3, 4. So how many devices? 2 to the power of 4 minus 2. Okay. Now let's do an example. Let's say /29. How many hosts can I have over here? First of all, let's find out what is the host portion. 32 minus 29 is equal to 3. Let's count and see. Yes, 1, 2, 3. Correct. It's 3. Now, 2 to the power of 3 minus 2. Okay, so that would be 6 hosts can be added to this network. So this network, you can have 6. I'm using a pen to write, but it's not so easy as it looks. Okay, at least better than the mouse. I've got this, a tablet where I can write. I guess we have to get used to it. So /29, that means 6 hosts. Okay. Now let's move on and try and explore these concepts a bit further. One thing that you should calculate is your network address. Okay. It's very important for you to know. The first thing is, what is my network address? In an IP version 4, if an IP address is given to you, you see here, I've given you an IP address, and I've given you a subnet mask. And next, I'm telling you, calculate your network address. How do you calculate your network address? We can calculate the network address by something known as ANDing. Okay? The concept of ANDing is, you take this, you see, 1 and 1, that means true and true is equal to true, 1. 0 and 1 is equal to, that means false and true is equal to false, 0. So you mention whatever IP address you have that is given to you and your subnet mask, and then do an ANDing. Once you do an ANDing, you get your network address. So you know your network address for this IP address is 192.168.10.0. How did you find out? You did a ANDing. Remember, your network address is not usable. Your network address tells you, in short form, what is the network address? You cannot give this IP address to any device. But you know that the first IP address over here, okay, is going to be 192.168.10.1. Okay, because you see, look at the subnet mask. It is 8 bits. 2 to the power of 8 minus 2. That is 254 devices. Okay. The last will be our, if this is the first IP address, will be 192.168.10.1. The last will be 192.168.10.254. This is straightforward, but I'll teach you another way of calculating it. Okay. So remember, if you want to find out your network address, you have to do ANDing. How do you do ANDing? Whatever IP address is given to you and the subnet mask, you just write it down in your binary format, and then you do an ANDing. Okay, like in this case, 1 and 1 is 1. 1 and 1 is 1. 0 and 1 is 0. 0 and 1 is 0, and so on. And then you get your network address. Okay? Another thing you have to remember, my dear students, is in an IP version 4 network, there are 3 main things. One is your network address, which I showed you how to calculate. The other one is your host addresses. That means you have to find out which is the first host IP address, which is the last host IP address. And the third thing is your broadcast address. Your broadcast address is your last address plus 1. I'll tell you what I mean. First of all, an easier way to calculate. Okay, for example, here I told you, if this is your network address, okay, your network address is 192.168.10.0. So the first IP address is 192.168.10.1. And the last one, since you know that it is 8 bits host portion, so 2 to the power of 8 minus 2, that means the last one will be 192.168.10.254. But always, it's not so simple to calculate. You have to do a better way of calculation. So how we do that is, what we do is, to this network address, you see, to this network address, do I have a slide after this? No, okay. To this network address, the first IP address, you see, the last, everything will be 0 in the network portion, okay? The last one, over here, we put a we put a 1. So 0, 0, 0, 0, 0, 0, 0, 1 will be this one. 192.168.10.1. So how do we know that this is our first IP address? At the host portions, start everything with 0, and the last one put 1. Okay? Like they have done here, see? There. All zeros and a 1 at the end. For the last address, we do the other way around. Okay? For the last address, we do the other way around. What we do is we put a 1 for everything. Okay? For all, we put 1, 1, 1, 1, 1, 1, 1, and at the end we put a 0. Okay? Like this. See? So for the first IP address in the network, in the host portion, put all zeros and a 1 at the end. For the last IP address in the host portion, put all ones and a 0 at the end. So when you do this, it will translate into 254. Okay, so you know how to give your first IP address, how to give your last IP address. And what is your broadcast address? Your broadcast address is your last IP address plus 1, which is 192.168.10.254. 255. That is why your broadcast address and your network address are not usable. The only thing you can use is your first IP address and the last IP address. Okay, the broadcast address is used to send the broadcast to all the devices in the network. Okay, now let's again go and do some exercises so we understand these concepts better. So what we do, we know based on this total number of hosts in a network is equal to total number of hosts, which is the host portion, 2 to the power of the host portion minus 2. Okay, I've taught you this since the beginning. So in this case, you know that looking at your network address, your host portion is over here. Look. Based on this subnet mask, your host portion is 8 bits. So 2 to the power of 8 minus 2, that means you can have 254 devices in this network. Now, so how do we find out what is the first IP address? Okay, how did I find out 192.168.10.1 is my first IP address? Very simple, you know, we just add a 1 to this. But remember, I told you that you have to do you have to do this special conversion. So your host portion consists of how many? 8. Okay, 8 host portion. So your first IP address will be all zeros, and at the end it will be 1. So it will be something like this. Okay, your first IP address is 0, 0, 0, 0, 0, 0, 0, 1. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Your last IP address is just the other way around. Okay, it will be 1, 1, 1, 1, 1, 1, 1, 0. And if you convert this, you will get your last IP address, which is your 254. Okay, so this is how you find out your first IP address and your last IP address. Okay, now you may say, why do you need to do that calculation? You can just put 1 and 254. It's very simple. Yes, it is very simple in this situation. What if instead of slash 24, your network is slash 16? Then perhaps it's much more challenging. Okay, we'll do some exercises so you get the drift of what I'm trying to tell you. Okay, so what is a broadcast address? That is 192.168.10 plus 1, 255. Okay, so this is an exercise that you're going to do next week, and you'll be tested again on this in your skill-based exam, where you have to find out your network address, you have to find out your broadcast address, you have to find out what is your first IP address, you have to find out what is your last IP address. Okay, so that's why usually in the skill-based exam, this is the most important thing. If you mess up your IP address, if you give the wrong IP address to your devices, that means you fail the skill-based exam. No, when you do a ping, they don't communicate. Okay, so this skill is very important. That's why you have to understand it. Okay, usually what students do, they go to these online IP calculators. Fine, you can do that, but then during your skill-based exam, I will ask you, how did you come out with this? You should be able to explain to me. If you cannot explain, okay, if you cannot do your ANDing and your conversion, that means you don't understand the concept. Okay. Now, let's do an exercise. IP address is 192.168.200.149. This IP address is given to us. Next, I will ask you, which is the host portion and which is the network portion? What should be your answer? Anyone? This is the IP address given to you. Very good, very good. Jian Yu? Very good. Jian Yu says not known. Why is it not known? Because I have not given you the subnet mask. Okay, so if I ask you in this IP address, which is the network portion, which is the host portion, your first question should be, excuse me, what is the subnet mask? No? Here, now I give you the subnet mask. Okay? Now that I give you the subnet mask, 255.255.255.224, now you can actually convert this, okay, into binary and find out how many is the network portion, how many is the host portion. First of all, let's find the network address for this IP address. This IP address, let's find out the network address. So we have the IP address, we have got the subnet mask. Let's do a ANDing. So first, convert this into binary. There. Yeah, we are trying to find the network address. So convert it into binary, it's done. Then the subnet mask, 255.255.255.224. Convert it. That's what we did. Now, 224 means you have taken, look over here, you have taken 3 bits from the host portion. Okay, so in this network, that means what kind of network is this? It is 8 plus 8 plus 8, 24, 25, 26, 27. So what kind of network is this? This is a slash 27 network. Okay, just do an immediate calculation in your mind. Now, how many host portion we have over here? Our host portion is 1, 2, 3, 4, 5. So immediately you can do a calculation. Okay, so how many devices we can have over here? That is 2 to the power of 2 to the power of 5 minus 2. Okay? That would be how many devices? That would be 30 devices. Okay? In a /27 network. Okay? Because we know that all the ones are the network bit and all the zeros are the host bit. Okay, we come to that calculation later. Yes, very good, Navendran and Daryl. Very good. Yes, correct. Yes, David, you're right. Right. Now, what we do, we try to find the network address by doing ANDing. Okay, so let's do an ANDing. So here we can say 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0, 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 0, 1 is 0, 0, 1 is 0. So we get our first one. Okay. Second one, 1 and 1 is 1, 0 and 1 is 0. This is 1, 0, 1, 0, 0, 0. So this is what we get. Then 1, 1, 0, 0, 1, 0, 0, 0. 1, 0, 0. Okay? 1, 0, 0, 0, 0, 0, 0, 0, 0. That's what we get. So our network address converted into decimal is 192.168.200.128. Okay, this is our network address. Okay, so the question that you have to now find out is, what is your total number of hosts is 2 to the power of host portion, which is 5. So that will be 2 to the power of 5 minus 2, which is 30. Okay, so which is your first IP address. Now you can say that you can just add the first IP at 30 means the first one would be 128 plus 1, so 129. Okay, 129 plus 30 would be 158. Okay, you can calculate like that, but that's not the ideal calculation. The ideal calculation would be, yes, broadcast address is 158 plus 1, which is 159. Okay, sorry. The ideal calculation for this, to find the first IP address and the last IP address, first of all, look at your subnet mask. What are you playing with? You're only playing with the last 5 host bits. Okay, 1, 2, 3, 4, 5. Okay, so the first IP address, remember, will be all, let me use the pen, will be all 0, 0, 0, 0, 1. So it will be 1, 0, 0. So this one translated, okay. Over here, what we do is, remember, our host portion is 1, 2, 3, 4, 5. Okay, our host portion is 1, 2, 3, 4, 5. So this is the amount that we can play with. We cannot play with any of these, only we can play around with this. Okay, with this. So my first IP address, remember, is going to be 0, 0, 0, 0, 1. So what is 1, 0, 0, 0, 0, 0, 0, 1? There, you get, just go to your calculator. There, 1, 0, 0, 0, 0, 1 is your 129. Okay? Yes, Cassandra, thank you very much. Yeah, initially I was right. But I forgot that this one is 129. In my mind, there was another number. Okay? Happens. We are all human. We make mistakes. Now, so over here, 10000, that means 129. So the first IP address is 129. Okay, this is the way you calculate, my dear students. What is your last IP address? Again, remember, you can only play with these 5 host bits. Okay, so based on that, we can say, remember, the last host bit, you have to make everything 1. That is 1, 1, 1, 1, 0. So what is 1, 0, 0, 1, 1, 1, 1, 1, 0? Let's find out. Okay, again, go to your calculator. Let's go to binary and let's type, what is it? 1, 0, 0, 0, 0, 0. Sorry. 1, 0, 0, 1, 1, 1, 1, 0. What is it? It is 158. Okay, so there it is. The last IP address is 158. So my dear students, this is how you calculate what is your first IP address, what is your last IP address. Okay. Now you can also, you can say that, okay, there are 30. So the network address is 128. So the first one definitely will be 129. 129 plus 30 is 158. You can calculate like that also if you want. But you should also know that the correct calculation is by taking the host portion, and to know the first IP address, remember all will be zeros and the last one will be 1. To know the last IP address, all the host portion will be 1 except the last one will be 0. Okay, so this is how you can find out your first IP address and your last IP address. Okay, this is the actual correct way to find out your first and your last IP address. Okay, but usually as network engineers, when they tell us that, okay, 128 and you can have 30 devices, so we can quickly calculate. The first one will be 129 and the last one will be, add a 30, 158. And the broadcast will be 158 plus 1, which is 159. Okay. So this is how we calculate our first we calculate our network address. Now that we have our network address, we can calculate what is our first IP address, and we can calculate what's our last IP address. And of course, we can also find out our broadcast address. This is going to be your exercise for next week. Okay. Next week, no packet tracer. Next week is calculation, where you do all these conversions of IP version 4 and show it to me. Okay. And this is something basic, my dear students. If you don't know how to do this, you fail Cisco exam, CCNA-1, you fail. Okay, that's why I keep telling you this one. You have to get used to it, Even see someone experienced like me, I got stumped. You can see how daunting this can be. So, moving on to IP version 4 unicast, broadcast, and multicast address. This is something which is unique to your IP version 4, okay? Unicast is sending from one IP address to another IP address. That means you have got one destination IP address. You send from one IP address to another IP address. Here, for example, a network printer. Okay, very straightforward. Broadcast means you send from one source to all the devices in the network. Okay, all the devices in the network will get the message that you're sending. Okay, that's why they call it broadcast. Every other device gets it. We also have a multicast. In a multicast, one device will send to other devices, okay, plural, devices, who are sharing, okay, a multicast group address. You see, all of these have got their personal IP address, but these two have got a multicast address, which is 224.10.10.5. So if we send it to that, so both of these will get these multicast address messages. Okay, so remember, we have got unicast, we have got broadcast, and we have got multicast. Now, there are different kinds of IPv4 addresses. If you look at the IPv4 addresses, we have, according to the IEEE RFC 1918, IPv4 addresses, they are globally routed between your ISPs, and there are certain addresses that are used as a private network address. That means every enterprise can give these private IP addresses. And these private IP addresses, you cannot put it on the network. Okay, you cannot put it on a, sorry, you cannot put it on a public network. You cannot put it on the internet. Okay, so, but privately, it can be something like this, starting from your here. It can be 10.0.0/8. Okay, that means network portion is 8 bits and host portion is 24 bits. Okay, so this can be the range, or it can be 172.16.0.0/12. Network portion is 12 bits. Okay, host portion is 32 minus 12. Okay, so this is the range. Or it can be 192.168.0.0/16, where network portion is 16 bits and the host portion is 16 bits. Okay, so this is the range. Okay, so this one, you can use it in your private enterprise. Every enterprise has got their own private network. Okay, depending on the size of your enterprise, depends how many devices you want to connect. Okay, and also depends how many subnets you want to create. We'll come to subnets later. For now, just remember, these are our private IPv4 addresses. Okay, and the reason we cannot put these addresses in the public domain is because these addresses are repeated in every enterprise. Okay, like in Curtin, we may have so many computers. We may have a computer which is, having an IP address 172.16.0.1. Okay, and then in another enterprise, we may have the same IP address, so we cannot put it on a public domain. There'll be a clash of IP addresses. Okay, but we can put it in a private domain. Okay, remember, in a private domain, a broadcast domain, that means a network where there is no router yet. Router is the gateway. Okay, in that one, you can use all your private addresses. There is a service. Before IP version 6 came out, we had a service known as NAT, Network Address Translation. Okay, you'll be learning about NAT and implementing NAT, not in CCNA-1, but rather in CCNA-2 and CCNA-3. Okay, what does NAT do? It takes your private addresses and maps it to a public address. Okay, so the public address will be what the users access. The public address will be mapped to your private address. So this was actually something that was something that was invented, like a temporary invention, until IP version 6 was deployed. Okay, but we still use NAT, and it's because if you want the IP version 4 network a private address to map to a public IP version 4 address, then we use a NAT. That is why when you do CCNA2 and CCNA3, you have to still be able to use NAT. Okay. Remember one thing, my dear students. You cannot say that now that IP version 6 is here, IP version 4 is, we're not going to use IP version 4. No. You are going to use IP version 4 in your private enterprises, in your private addressing. Okay. So that is why you have to still learn IP version 4 as well as IP version 6. Okay. We also have a loopback address. Now, the loopback address is commonly identified as 127.0.0.1. Okay. You usually use this to check whether your TCP/IP is working. Okay. We also have a linked local address. Okay. This is used by Windows DHCP clients to, self-configure when no DHCP servers are available. DHCP server is a special device, usually not a computer, but a router, where what you do is you make the router give IP addresses to your network devices. Automatically, it gives, you program your router. Again, this is something you study in CCNA2. You configure, rather than program, I should say configure. You configure your router by giving it a pool of IP addresses. Okay, for example, you say, I want you to have this pool of IP address 192.168.0.1 to 192.168.0.254. So this pool of 254 IP addresses, give it to every device that connects to this network. You can configure this on the router. So your router becomes your DHCP server. Now you can do this through a router. You can also do it through your a device, a computer. Okay, but usually we assign a router to do that. Okay, and just remember that this linked local addresses, okay, they are commonly known as automated private IP addresses or self-assigned addresses, and it is used by your DHCP clients when you don't have a DHCP server. So far, we have given IP addresses to our devices in packet tracer by we ourselves type the IP address, a static IP address. But in the real world, just imagine, in Curtin, how many computers do we have? We got thousands and thousands of devices in Curtin itself. Now just imagine the network engineer and his IT helpers have to go to every device and give an IP address individually. They'll go crazy. That is why we need a DHCP. We need a DHCP server to automatically give assigned IP addresses. Okay, so the network engineer can program. The moment you connect your device, okay, you can look for a DHCP server. Okay. So the moment, let's say, okay, the moment you connect your device, okay, when you go to IP configuration, rather than giving a static address, you select this DHCP. Okay, and then it will automatically look for a DHCP server and give a automatic IP address. Okay, so this is how it's done. So far, we have been giving static, but in the real world, nobody does this. Okay, unless you have a very small network. Okay, usually people select this. Okay. And remember your loopback address, you can actually find out. You can just go to your command prompt and you can actually go here and you can type loopback. Ping loopback. There. So you see over here, it shows you colon, 1, because this is your IP version 6 loopback. Okay. I can also use my IP version 4 loopback, that is 127.0.0.1. There. TCP/IP is working just fine on my computer. No problem. Okay. So according to RFC 790, okay, came out in 1981, we have got 5 classes. Class A, here is the range. Class B, here is the range. Class C and Class D. Okay, that's why 192.168.0.0, which is normally assigned to Class C. Okay. The problem with these classes addressing and this class addressing, it wasted many IP version 4 addresses. For example, if a company just stuck to Class A and did not employ others, there were wastages. Okay. So that is why class full addressing, we don't follow this anymore. We follow the classless addressing, where we do not follow the rules of A, B, and C. So we don't say that, okay, in this network, we only have this range, or this range, or we follow only class C. No. Okay. We sort of depends on our network. We may even have a mix of addresses. Okay. So that's why we need to understand the concept of segmentation, the concept of subnetting. Now, when it comes to public addresses, okay, we have got IANA. It manages and allocates blocks of IP version 4 and IP version 6 addresses to all our regional internet registries. So we have got, if you look, North America, that means 2 main countries, Canada and USA is RIN. South America, including Mexico, is LAC and IC. Europe and Middle East is RIPE. Africa is AFRI and IC. And our region, Asia, is Asia Pacific and IC. Okay, so this is our region, including Australia. Okay, so not taking into account the Middle East, okay, the Asian countries over here, the major countries, India, including Afghanistan, including Mongolia, China, and Australasia. Okay, all of them are under AP and IC. Okay, so these are responsible, these regional internet registries are responsible for giving IP addresses to the internet service providers. Okay, public IP version 4 addresses. Okay, so that there's no clashes. Next, we are going into network segmentation. Now for that, let's take a small break. Okay, continuing with where we left off. So, segmenting a network, my dear students. First of all, why do we want to take a network and segment it? You should be happy with what subnet mask is given to you. You don't need to further segment it. Turns out that actually we do need to segment. There is a reason that we need to segment. Okay. Now, think about what happens in a network. I'm talking about a network. Look at the router here. We're not interested in the router. We are interested in the network here. We are interested in this network. Okay, minus the router. Now, what happens in a network? You have a lot of uh, messages, lot of pings, lot of broadcasts, okay? Lot of ARP using broadcasts to locate other devices. Remember we studied ARP? Host send DHCP discover broadcast to locate where is the DHCP server. So many exchange of data inside a network. And you see, the issue with switch is they propagate broadcast network. A router is a broadcast killer, okay? But inside the network, the switch always broadcasts. These network, they are the they propagate broadcast network. And ideally, this would not be suitable and make the network optimal. It will make your network slow, okay? So in situations like this, okay, when you have got a large network, okay, and you have got a lot of switches, you see, you have got switches connected to an aggregate switch, and perhaps those aggregate switches will be connected to a main aggregate switch. So you have got broadcast network over broadcast network, and this will create so much broadcast that it will negatively affect your network. In other words, it makes your network slow. And as network engineers, that is the worst thing that you can have for your network, okay? Because people will judge you. People will say, what kind of network engineer is this? Okay, network always slow, always slow. They'll keep connecting your competence with the speed of the network, okay? That is the reason we take this large network and we segment it. We divide it. That is why we have got subnetting. An example over here, you see they have one network. Look at the IP address 172.16.0.0. Okay, so 16 bits is network portion. Host portion is 16 bits. Okay, so host portion is, if you look, host portion is 16, correct? So 2 to the power of 16 minus 2 is equal to, let's again go back to our calculator. Okay. Two to the power of 16 minus 2. So we can have there. Of 65,534 devices. Okay. But here they have only 400 devices. If you look, only 400 devices is what they have, which is okay. Now the issue is it makes the network slow. So what we do is we subdivide it. We take your /16 network, okay? We can subdivide it, you see, in /16, if you look, you have got 16 for the network, you have got 16 for the host. Now what we do, we subdivide it into two networks by taking further 8, okay, from the host. When you take further 8, then the host becomes only 8. And the network becomes 16 plus 8 becomes 24. So we divide a /16 network into 2 /24 networks. Okay? And we know that in a /24 network, the host bit is 8. So 2 to the power of 8 minus 2 is equal to, we know that it is 254 devices. So here we have subdivided your 400 into 200 users and 200 users. Okay. So this network, my dear students, will be much more faster than this whole big network. Okay. Our main goal is to kill our broadcast domains so that our network becomes faster. That is why we do subnetting, segmentation. Okay. Now, keeping that in mind, pay attention. This is important. Where do we do subnetting? Depends on the situation. Depends according to your institution. If your institution consists of different departments, like administration will be one subnet, human resource will be one subnet, accounting will be another subnet, and students will be another subnet. If you are in an institution that you own a high-rise building, then perhaps you can subnet where every floor is one subnet. Okay. Or you can also divide according to, you know, your device types. Here we can have one kind of hosts. Here we can have only server. Here we can have normal workstations, only servers. Here we can have only computer, only printers, and so on. So it depends how. That's the whole idea is for you, when you go to an enterprise as a network engineer, you have to ask for the blueprint of their network. Once you get a blueprint of the network, you can understand how they have done the network division. Okay. It will show where are the switches, where are the aggregate switches, where are the routers. Okay, some institutions, you'll be surprised, they have only one router. That means the whole network, the whole big network is one big, huge broadcast domain. And then I keep wondering, how come it's so slow? Because you haven't subnetted. Okay. Okay, that's why you have to employ uh, multiple subnets. And remember another thing, the moment you subnet, the moment, okay, see here, the moment you convert this into this, you have two new networks here, 172.16.0.0. Here the network is 172.16.1.0. Now this network cannot communicate directly with this network because they are two separate networks. Look at the network address here. Look at the network address here. You need a special device to make the connection, and that special device is a router. Right from the first lesson, I told you the difference between a switch and a router. A switch is used to connect the similar networks. A router is used to connect to separate networks. Okay? So these are some of the reasons that we need to subnet. We have to plan how to subnet. And remember, when you subnet, when you segment your network becomes faster. Now let's actually go and learn the tricks of subnetting and IP version 4. Okay, this is important. How do we subnet an IP version 4? So wake up alert, pay attention. Okay, now the easiest way to subnet is at the octet boundary of /8. There, you know that in /8, your host portion is, sorry, your network portion is 8, your host portion is 24. So 2 to the power of 24 minus 2, that means 16, more than 16 million devices you can connect. Wow, to this network. Okay. Now, imagine you have got 16 million devices on a network with multiple switches. Just imagine how slow that network will be. Or you can have, you know, a prefix 16 where you have got 16 bits for network and 16 bits for hosts. How many devices? 65,000 over devices. Or a standard /24, where you have got 24 bits for the network, okay, and 8 bits for the host. Maximum devices is 254. Okay. Now, let's do a subnetting of perhaps our 10.0.0.0/8. Okay. So we are going to subnet it. Okay. First, in the first table, we are going to subnet it into /16, and in the second table into /24. Now, first of all, when you subnet, you have to ask yourself, how many subnets we have to create? I mean, how many subnets you can create? Okay. If you take your, if you take this /8 and convert it into /16, /8, that means 8 bits is for the network, 24 bits is for the host. Now, if you're converting this into 16, that means you are taking 8 bits from the host portion. When you take 8 bits from the host portion, this is how you calculate, my dear students. 2 to the power of 8, that means you can create 256 subnets. There, 256 possible subnets. If you're converting this into this, okay, how did I calculate? I'm converting a /8 to /16. So I'm taking 8 bits from the host portion. So these 8 bits that is added over here to make it 16, just say 2 to the power of 8. That means 256 subnets are created. What about if you want to convert this into this? In that situation, that means you're converting 8 into 24. That means you're taking 16 bits and adding it over here. So in that situation, that means 2 to the power of 16, you can create 65,000 over subnets. Okay. So it depends how many subnets you want to create. Now, even if you are creating, for example, the first one, if you're creating 256 subnets, in each subnet, you see, starting with this subnet all the way until 10.255.0.0/16. Okay. From here to here, in each subnet, okay, how many devices you can add. Okay. You can calculate that as well. For example, here, that means 16 bits is for the host. 16 bits means 2 to the power of 16 minus 2. You know how to do this calculation. Okay. So that will give you 65,534 hosts for each subnet. In this case, you can have 65,536 subnets, and each subnet you can have 2 to the power of 8 minus 2. That is 254 possible hosts per subnet. Okay. So the question is, how do you again calculate in this situation? Your network address would be this, right? 10 is 101.0.0.0.0. So this is your network address. So what is your first IP address? Remember, it's a /16. /16 means you're playing around with the last 16 portion of the host bits. So what would be your first IP address? How do you come out with this? There. You take this 0.0.0.0.0 and put a 1 at the end. Okay, so this will be 0.0.0.0.0. So it will be dot, here 0000001 means 10.0.0.1. What is your last IP address? Your last IP address, remember, this is a /16, so we are playing around with this, okay? So that means, let me take the pen, hold on. This will be 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Last one, 0. Okay. The first one, everything is 0. The last one is 1. The last one, everything is 1, and it is 0. So this will be, if you convert it, so it will be 10, yes, dot 0 dot, this is 255 dot, this is 254. Okay, the last device. What is the broadcast address? 10.0.255.255. Get it? Okay. You do this quick enough. You do this long enough, you become so quick at it. And you'll become expert network engineers. Okay. You can also subnet your /24 network. Okay. You can convert your /24 network into /25, /26, /27, /28, /29, and /30. This is the last you can go, because you cannot, the last host bit should at least have 2 zeros. You cannot take more than that. Okay, it's not allowed. So your /24, if you make it into /25, what does that mean? That means you have taken 1 bit from the host portion. That means 8 plus 8 plus 8, 24 plus 1, 25. Since you have taken 1, that is 2 to the power of 1, that means you can have 2 subnets. How many hosts? 1, 2, 3, 4, 5, 6, 7. Remember, hosts count as 0. 2 to the power of 7 minus 2 is 126. Devices can be connected. /26, you are taking 2 from the host portion and making it network portion. Okay, 2, 1, 2. Okay, so that means 2 to the power of 2, which will be 4. Okay, 2 to the power of 4. That means in /26, you can create 4 subnets. And each subnet will have 1, 2, 3, 4, 5, 6. 2 to the power of 6 minus 2. 62 devices. Next, in /27, that means in /27 is 8 plus 8 plus 8, 24, 25, 26, 27. You're taking 3 bits from the host portion. So how do you calculate? 2 to the power of 3. That means you can create 8 subnets. Okay, 8 separate subnets. This table is important for you to remember, because in future, if you want to convert it into subnets, you have to refer to this table. And each subnet, how many devices? 1, 2, 3, 4, 5. 2 to the power of 5 minus 2. 30 devices. In a /28, you are taking 4 bits from the host portion. So 24, 25, 26, 27, 28. 4 bits. So 2 to the power of 4 is 16 subnets. Each subnet will have 1, 2, 3, 4. 2 to the power of 2 to the power of 4 minus 2 is 14 devices. And so on. /29 means you are borrowing 1, 2, 3, 4, 5. 5 bits from the host portion. So 2 to the power of 5 is 32 subnets. Each subnet, how many hosts? Look, 1, 2, 3. 2 to the power of 3 minus 2 is 6 hosts. Finally, /30. /30 means you are taking 1, 2, 3, 4, 5, 6. 6 bits from the host portion. So 2 to the power of 6 is 64 subnets. How many hosts per subnet? 2. Only 2. That means 2 to the power of 2 minus 2. In each subnet, only 2 devices. Okay. Now, remember I told you, you may be wondering what is the use of this. There is a special use for this. Specially used when you're connecting a router to router, direct connection. Then they have 2 devices, correct? So this will suffice for that. Okay. Now we'll come to that later. So let's move and create a subnet for a 16 and a 8 prefix. Here, creating subnet with a 16 prefix. We are converting our /16 into /17. /17 means we can create 2 devices, and 2 devices means each, and we can create 2 subnets. 2 subnets means each subnet will have 32,766 devices, okay, or hosts. /19 means, again, you're taking 3 from the host portion because you're taking 16 and adding another 3 to make it 19. So 2 to the power of 3 is 8 subnets, and each subnet can have 8,190 devices. Now, why this table and calculation is important is because you have to create a subnet and you have to ask yourself the question. The first question you have to ask yourself is, how many subnets do I need to create? The second question you have to answer is, how many devices per subnet? Based on that, you will choose the relevant, okay? Based on that, you will choose the relevant scheme, okay? Let's go through an example. Now consider a large enterprise that requires at least 100 subnets. Whoa, 100 subnets, and has chosen a private address 172.16.0.0. This is your network address. It's a /16. That means 16 bits are for the network, 16 bits are for the host. And this is your network address. You need to create 100 subnets. So immediately go back to this table, okay? You need to create 100 subnets. Just go down here. Is this enough? No. Is this enough? Yes, there we are. So we have to convert our /16 into /23. Then we will get more than 100 subnets. I cannot convert it into /22 because that will have only 64 subnets. The requirement is 100 subnets. Okay? So, how many I can borrow over here? You see how many I can borrow? How many hosts? 1, 2, 3, 4, 5, 6, 7, 8. Okay? If I borrow 8, then I will have 256. No, that's too much. Perhaps I need to borrow over here until this place, because according to the requirement, I need 100. So I just borrow over here until this place. 1, 2, 3, 4, 5, 6, 7. 2 to the power of 7, 128. So this will suffice. Okay. So again, going back to the table, you can see it will be a /23 network. Why do we say /23? Because if it is 16, I'm borrowing 1, 2, 3, 4, 5, 6, 7. 7 bits from the host portion. Okay. So 16 plus 7, 23. tree/23 network. This gives me 128 subnets, because according to the requirements, it says I want 100 subnets. So that's why I choose a /23 network. It doesn't say how many devices, my dear students. It just gives the priority that you need to create 100 subnets. Okay. Another example. Look over here. Consider a small internet service provider that requires 1,000 subnets for its clients using the network address 10.0.0/8. That means 8 bits for the network portion. So network portion is 8 bits and the host portion is 24 bits. Okay, just immediately calculate 32 minus 8, that means 24 bits. So it requires 1,000 subnets. Okay. Now what you need to do is, in order to get your 1,000 subnets, you have to again calculate. You have to take, okay, if I take one host bit from the 24 host bits, if I take one host bit, that means to the power of 1, 2 subnets. If I get 2, 4 subnets. If I get 3, 8 subnets. Now, the requirement is 1,000 subnets. So if you go down over here, you can see you have to borrow 10 bits from the host portion. So you have to borrow 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 until here in order to create your 1,000 subnets. Okay? So you get an idea of how to convert into a subnet. Now, to understand these concepts better, we're going to do perhaps some exercises. But first, you have to understand that usually in an enterprise, there are 2 sections. You have got your intranet. You have got your public IP addresses where you put it, IPv4 public addresses, which is your DMZ, okay? And we have got a router which connects all of them, and it connects you to the internet, okay? Your DMZ, where you have got your, like your Moodle website and all the other websites that you need to access from outside the campus, you put it in your DMZ section, okay? Why are you saying Yala? Hi. How is that? Something you want to say? Okay. Okay, so here is how a traditional network is, okay? So remember, when you're creating a subnet, you have to take into consideration 2 main things. First of all, how many subnets you want to create, and second, how many hosts per subnet. You have to ask yourself that question, okay? So let's say over here, in this situation, they tell you, a corporate headquarters has been allocated a public network address of 172.16.0.0/22. /22 means network portion is 22. Host portion is 32 minus 22, which is 10 host bits. Okay. So, you are saying over here, that means there are 5 sites and therefore 5 internet connections, which means the organization requires 10 subnets, 5 sites. You see, site 1, 2, 3, 4, 5. These 5 sites require a separate subnet. That means, of course, there will be their own network. At the same time, there will be a router connection to the ISP, which is another site, which is, another subnet. 1, 2, 3, 4, 5. So 5 plus 5, 5 subnets are required. Okay. So we have to take our /22 network. Okay. There. Remember, your /22 network means this is your subnet mask. 8 plus 8, 16, 17, 18, 19, 20, 21, 22. Correct? This is your /22 network. Now, what you have to do is you have to convert it into a network of, it says you need 10 subnets, and each subnet 40 addresses. Okay. So if you convert this into subnet mask, it will be 255.255.252.0. Okay, for your /22. Now convert your /22, my dear students. Okay. Because in your /22 network, if you look at the table 16, right? It says, yeah. Sorry. Yeah. If you look at your /22, I have it over here. If you have /22 network, you can have 64 subnets, and each can have each subnet can have 1022. Okay, now we don't need that much. It says that take this, because again we can leave it as it is, but then the network will be very slow. So we want to take our /22, okay, and as it says, our priority is 10 subnets and 40 addresses. First important thing is 10 subnets. Okay, let's look at 10 subnets, and the second priority is 40 addresses. So if you want to subnet this, okay, so look at this. Okay, 10 subnets and at least 40. So if you go down the list, you can see over here itself, you see there, between 30 and 62, that means we can go for this. Okay, 62 addresses, okay, and 1024 subnets. So we can further divide this into /26 to meet our goal of 40 devices per subnet. Okay, so that's what we do. Okay, we allocate 10 subnets with a /26. That means here your 22, then we add 1, we take 22, 23, 24, 25, 26. Okay, we take these 4 host bits also and add it and make it /26. Now we have only 1, 2, 3, 4, 5, 6. 6 host bits. So 6 host bits means you can have 2 to the power of 6 minus 2, that is 62 devices. Okay, and our requirement here, it says, should be 40 devices. And we have addressed it. It is done. Okay, so, sorry, it is done. So what we do here, you see, this would be my first, okay, 172.16.0.64. This would be another one. First, let's look at the main addresses, 172.16.0.64, 172.16.1.64, 172.16.1.192, 172.16.2.64. Okay, there it is, all the network address looking into /26 addresses. That's what we are subdividing it into multiple subnets. So these are the 5. Again, we can create another 5, you see. 172.16.0.0, 172.16.1.0, 172.16.1.128, 172.16.0.128, and so on. Okay. Taking your /22 network and converting it into /26 network. Now there's something called variable length subnet mask. Okay. The issue is we don't want to waste our IP addresses. You see over here, look at this topology. This is a /27 subnet mask. Okay, and if you are following a /27, that means you have got over here /27. If you look, that means you can create 8 subnets. You see, because you're taking 3 bits from the host, 1, 2, 3. 2 to the power of 3 is 8 subnets. And 1, 2, 3, 4, 5. 2 to the power of 5 minus 2 is 30 hosts per subnet. Okay, so this is okay because it says over here, given the topology, 7 subnets are required, and each subnet, the largest number of hosts is 28. So 7 subnets and 28 hosts. So does this satisfy? Does this satisfy? Yes, it does. We need 7 subnets, so 8 is the best over here. So this one, it is within the range. And how many devices it says? 28. So here we can have each subnet 30. So yes, we can go for this. No problem. We can go for this. But if you go for this, observe, if you go for this /27, no problem, you go for this. It's okay for this. It's okay for this because here you have got 25 hosts. So how many are wasted? 30 minus 25, 5 are wasted. Here you have 20 hosts. How many are wasted? 30 minus 20, 10 are wasted. Here you have got 15 hosts. How many are wasted? 30 minus 15, 15 are wasted. Here you have got 28 hosts. How many are wasted? 30 minus 28, 2 are only wasted. Now, look between this router to router connection. 2 hosts. 30 minus 2, how many are wasted? 28 hosts are wasted. And this wastage is happening once, twice, 3 times. So how many total wastage are you doing? 84 addresses are unused and wasted. So the question is, why do you want to do this? When you're connecting 2 routers, 2 nodes together, why do you want to use a /27? Rather, use VLSM. Use something else. Okay? So what do you think we should use to give, which subnetting we should do to convert your /27 to which range so that we can have only 2 IP addresses? Anyone? Again, go back. Yes, very good. Who is this? Yes, Jianyu. Very good. Go back to the table. Go back to the table. You are looking only for 2 hosts. Okay? 64 subnets. Over here, how many subnets do you want to create? Just 1, 2, 3. Okay? 4, 5, 6, 7. Yes. But here the subnets is 64. It's covered within that. But our main priority is 2 hosts. So 2 hosts means here. We go for /30. Remember I told you people are wondering why /30? Who would go for this? We would go for this when we are connecting router to router so that we don't do this wastage. Okay? This kind of wastage we don't have to do. Okay? So that is why we follow VLSM in certain situations. Make sense, my dear students? Okay? So in this situation, rather than following that, what we do is we take your subnet and further subnet it. That means we take your /27 and convert it into /30. Okay? We further subnet it. Why? Because when we further subnet, there we have, when you further subnet it, you have got 224, 228, 232. Okay? When you further subnet it like that, then you can have only 2 IP addresses. That is this router to this router connection. Okay? It'll be fast. Again, here, only 2 IP addresses, 2 hosts. Over here, 2 hosts. Okay? So this is typically used from router to router connection. Okay? Usually your serial connection. Okay? So you get an idea of, where we use your VLSM. So remember 2 considerations when you are planning your subnetting. Either the consideration is how many subnets, or your consideration should be how many hosts. If your priority is I need only 2 hosts, then you go for this. If your priority is I need, for example, 32 subnets or 30 subnets, then you go for this. Okay, the table is given to you. You can just refer to it or do the calculation and find out your answer. So over here, observe, in my /27 network, over here, I can have 25 hosts. Here, actually 30 hosts. It's okay. 25 is within 30. 5 are wasted, but then I may add new ones here. 20, here 15, here 28. And over here, nothing is wasted. /30 means 2 hosts. There, router to router is 2 hosts. Router to router is 2 hosts. Router to router is 2 hosts. Nothing is wasted. Okay. So I have taken my /27 and further divided it into subnet. That is subnetting a subnet. When you create your network, my dear students, your task should be to create a design, okay, a structured design as network engineer. That's why whichever company you go to, any company you go to, network design and network structure is fundamental. We don't have any company in this world that does not use computers. All of them use a computer. That is why a network engineer has got a very important position in any company. And as network engineer, what you have to do is have access to that blueprint. Or if you are the network engineer, you have to upgrade, because when you leave, the other person who takes your job is going to refer to that blueprint. And that blueprint is, my dear students, something which is a very closely guarded secret. Okay? And they don't just reveal what it is, okay, to anyone, especially computing and electrical engineering students. Okay, they don't just reveal that topology to everyone. So anyway, as network engineers, you have to find a solution which is also scalable. Scalable means you can add new components. You can take your /24 uh, uh, network and convert it into /27. You can subnet whenever you want. Okay, so you should know how your organization's network is and how they use it, what kind of internet connection you have. Okay, you have to do a lot of tests, a lot of packet tracer, a lot of, perhaps use Wireshark to do uh, a lot of tests of your network to see the speed of your network. Okay, as network engineers, when you go into detail into CCNA2 and CCNA3, there's so many tests to find out the speed of your network. Okay. So you have to do a lot of planning. That's what they are saying. So one aspect of your planning is IPv4 addressing. Okay. You have to, decide which device uh, they need addresses. What are your end user clients? Which address are you going to give to server and peripherals? Which servers, like a Moodle server, has to be accessed from outside, from the internet. So what IP address you're going to give to that? You have to access it from the internal network as well as from the outside. What are your intermediary devices? Usually we have been doing this practice in the lab. The first IP address we give to the gateway, to the router, remember? Okay. Are you going to follow that policy or you're going to do something else? So you should have, the whole idea is you should have a set pattern of how addresses are allocated to each type of device and put that in your blueprint. Okay. Now that brings us to the end of today's session. Yes. Anyone has any immediate questions? Okay, I hope you understood something from what I have explained you today, and you were not like me. The first time I went through this session, my lecturer taught me it was a big blur, seriously speaking. But I hope the way I presented it has made some difference. If it hasn't, perhaps you can watch the video again when I upload it to Moodle. Please watch it again. And perhaps again, watch the previous videos, okay, as well. The more you watch, the better you get at, doing the calculations and the subnetting. And I implore you, please do the subnetting calculations using pen and paper. Do not use an IP calculator online. That IP calculator you can use when you are trying to check your answer, okay? Because you should know how to do your ANDing and how to find out the first IP address and the last IP address as I taught you. And it's not exactly rocket science, it's very simple. Okay, thank you very much. I'm going to stop the recording now. Wow, almost 2 hours.